Good morning, everyone. Thank you for joining us. We really appreciate you joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, Apple Valley, California.
Science and Technology Channel. Science, all technology.
We're not the experts.
We are not the experts in anything.
But
just
we're the
listen
messengers.
to us and you'll know that.
It's really good stories. And I say that every day. I say, wow, this story is interesting. This one's interesting.
Yeah.
The solar system drifts inside an immense low-density cavity known as the local hot bubble, LHB. This region, spanning at least 1,000 light years, radiates X-rays due to its searing million-degree temperature. Yet, because its atoms are so sparse, this extreme heat has little effect on the matter within. While this has allowed life on Earth to thrive undisturbed, the LHB itself has remained an astronomical mystery. Would you like to know more?
Scientists believe that long ago, supernova explosions sculpted this vast bubble, blasting away surrounding interstellar gas. A sequence of stellar detonations likely carved out the region, leaving behind a hot X-ray emitting void. However, only recently have researchers begun to map its true shape and structure in detail.
Isn't that incredible? I mean, how Heavenly Father creates that, over so much time. And he's eternal. Heavenly Father, no beginning, no end,
Right. And how would they have discovered this? It's amazing.
Telescopes, which we're going to have an episode tomorrow about interesting optical thing that you put on a telescope that makes it even clearer.
Magnifies it even more?
Yeah, well, it accounts for the oscillations from the atmosphere. So it's just like a space telescope, but it's on Earth.
Okay,
it's pretty
stay
cool.
tuned for that.
Yeah. A team at the Max Planck Institute for Extraterrestrial Physics, MPE, led by astrophysicist Michael Yang, has now provided an unprecedented look at the LHB using the Rosita X-ray telescope.
Okay. I'm glad you said that.
Or E-Rosita. E-Rosita. I don't know.
Yeah, that's how
they created the most detailed map of this cosmic bubble yet, positioned 1.5 million kilometers from Earth, which that's close. It's not like light years,
Right.
E-Rosita avoids interference from Earth's hydrogen halo, giving it a pristine view of the X-ray sky.
To analyze the bubble structure, researchers divided the sky into 2,000 segments, examining X-ray emissions in each. That's fascinating. Their findings reveal that the LHB isn't a uniform sphere. Instead, it expands more easily perpendicular to the galactic plane, where it faces less resistance compared to the dense horizontal disk of the Milky Way.
The Milky Way is this little spiral frame.
Right. Michael Freiberg, an MPE scientist, compared the bubble's shape to a bipolar nebula, but noted key differences. Quote, "It's spikier and bumpier," he explained.
Okay.
This irregularity suggests that the LHB's evolution was influenced by multiple factors beyond simple supernova explosions.
One of the study's biggest surprises was an interstellar tunnel extending toward the constellation Centaurus. This previously unknown gap in the cooler interstellar medium appears to act as a passageway, allowing hot gas from the LHB to escape. Quote, "What we didn't know was the existence of an interstellar tunnel towards Centaurus, which carves a gap in the cooler interstellar medium," Freiberg said.
The tunnel isn't just an isolated feature. The team's model revealed a temperature gradient within the LHB, with the northern region being hotter than the southern. This suggests that recent supernova events may have reheated parts of the bubble within the last few million years.
Yeah, a few million, give or take, right?
Yeah, like yesterday.
Yeah. The LHB has fascinated astronomers since its existence was proposed over 50 years ago. Initially, scientists used the bubble to explain mysterious X-ray emissions that shouldn't have reached us through the dense interstellar medium. The theory gained traction as observations revealed a relative void of interstellar dust near our solar system. Challenges emerged in the 90s when scientists discovered that solar wind interactions with Earth's geocorona could also produce X-rays, but recent data from E-Rosita, which observed the sky during a solar minimum, confirmed the LHB's role in these emissions.
Michael Yang highlighted E-Rosita's contribution, stating, quote, "E-ROS-1 data provides the cleanest view of the X-ray sky to date, making it the perfect instrument for studying the LHB. The detailed 3D model constructed by Yuang's team paints a vivid picture of our cosmic neighborhood. I never thought about it that way, I guess. It includes known supernova remnants, molecular clouds, and even other tunnels, like the Canis Majoris tunnel, potentially linking the LHB to Gum Nebula.
The Gum Nebula.
Okay.
Where do they come up with these
I don't
names? Does it look like
Maybe
bubble
it's
gum?
sticky.
Like a
I
big
don't know.
bubble blowing?
I don't know.
Some dense molecular clouds near the bubble's edge have velocities suggesting they formed from materials swept up during the bubble's early formation. Co-author Gabrielle Ponti noted, quote, "The sun must have entered the LHB a few million years ago, a short time compared to the age of the sun," end quote. This central positioning of the sun within the LHB is purely coincidental. Okay, I don't believe in coinkydinks. As the solar system moves through the Milky Way, we're likely just passing through this cosmic cavity.
The discovery of the Centaurus tunnel could mark the beginning of a new chapter in galactic exploration. If the Milky Way is indeed a vast network of hot bubbles and tunnels, studying these structures could reveal the galaxy's dynamic history. The study, published in Astronomy and Astrophysics, emphasizes how stellar feedback, energy released by dying stars, shapes the interstellar medium. As researchers continue to analyze eRosita's data, we may soon uncover more secrets hidden in the vast expanse of space.
Superbubbles are vast cavities in space filled with hot, low-density gas, often created by the combined activity of supernovae and stellar winds from massive stars. The LHB is the closest superbubble to Earth. The next superbubbles are Loop 1 bubble, distance about 400 500 light years from Earth, and its description is a large superbubble associated with the Scorpius Centaurus OB association. It is thought to have been created by multiple supernovae and stellar winds from massive stars in this region.
Connection to local bubble. The Loop 1 bubble interacts with the local bubble, forming a boundary known as the interaction zone. Orion Eridanus. Eridanus. Okay. Yeah, I'm not getting all my vowels in there, am I? Orion Eridanus superbubble. Distance approximately 500 to 1,000 light years. Description: located in the Orion and Eridanus constellations, the superbubble was formed by supernovae and winds from the massive stars in the Orion OB1 association. Features: it encompasses the famous Orion Nebula and extends towards the Eridanus constellation.
I just want to add here that the people in Orion, those are the green skinned people. We saw that on Star Trek. They were completely green skinned. And the females are very erotic and the males are like bulky and, you know.
Okay.
So, yeah. So that's
like
Orion.
So it's a gym.
Like the Orion
They
Syndicate.
live at a gym location then.
Yeah, the Orion Syndicate, they were like gangsters, right? Okay. Loop 2 and 3 bubbles. Distance. Both are several hundred light years away. Description: these super bubbles are associated with other star-forming regions and supernova remnants that are less well-defined than Loop 1. These superbubbles play a significant role in shaping the structure of the Milky Way, influencing star formation and the dynamics of interstellar gas.
So we usually have, on a clear night, we usually have a really, really good view of the Milky Way.
Especially when you get out to the desert. Yeah,
get to the desert where it's pretty dark. Or if there's no moon out there, you can see it. But yeah, it's pretty cool to see that.
Yeah. So I wonder if this interstellar, if you travel through, if it's like Deep Space Nine, Star Trek Deep Space Nine, where it opens up and you get to the Delta Quadrant.
And you can't see when you're traveling through that?
Right. No.
Wow.
Sensors are kind of muddled. Yeah, and then you just pop out to the Delta Quadrant, and then you come back through and transit and get back to the Alpha Quadrant.
Space tunnel. Interesting.
There's a movie called Interstellar, which has a sinister role for who's Jason Bourne? Marky Mark? No, that's not Mark.
Matt Damon.
Matt Damon. Very sinister role for him in that, which I was completely shocked watching that movie, Interstellar. The way he acted.
I haven't seen it. I've seen
good actors.
I've seen the Bourne movies, but yeah.
I know what I was going to say earlier. Remember, I said I couldn't forget. It must not be important.
Right.
Last night I watched the final episode of Cobra Kai, season 6 episode, whatever. And it was a feel-good episode. I really liked it.
Okay.
That's all I wanted to say.
Leave your comments if you've seen it.
Okay. Thanks, folks.
Take care, everyone.
We'll
Thanks.
see you.